Hello again. As you know, I'm Eli the Computer Guy over here for EliTheComputerGuy.com and EverymanIT.com. Today's class is IP surveillance cameras. So this is yet another class in the digital surveillance system track. We've done introduction to digital surveillance systems so far and digital surveillance cameras. With this class today, we're going to talk more about IP cameras. So in the digital surveillance camera class, we talked about things like box cameras and bullet cameras and dome cameras. We talked about infrared cameras, low lux cameras, etc. All of those concepts remain relevant for IP cameras. The difference between IP cameras and analog cameras is how they transmit the video and how much intelligence each one has. As I talked about in the digital surveillance camera class, analog cameras are basically dumb. They have a few configurations you can set, but that's it. They're about as complicated as an old-fashioned VCR. IP surveillance cameras, on the other hand, are full-fledged computers that happen to process video. So with the old analog cameras, you're dealing with an old VCR. With the new IP cameras, these are actual computers unto themselves. So they have a camera on them, they normally have a web server built in. There is a whole bunch of stuff that you can do with IP cameras that you simply cannot do with analog cameras. This class is going to go into some of that functionality and explain this to you more so that you understand what's going on with IP cameras. So, as I said before, this is IP surveillance cameras. I'm Eli the Computer Guy, and if you give me a second, we'll dive into this class. Up until this point in the series, we've mainly been talking about analog surveillance cameras. So with analog surveillance camera, it's basically a dumb little device. There might be a few configurations that you can change in the analog camera, but you can't do a whole lot. Essentially, it's a lens, it's a camera. You plug that camera into a wire that goes back to the DVR, and then the camera constantly sends video back to that DVR, that digital video recorder. The DVR is the only thing in the system that has any real intelligence, any real programming. So in the DVR, you can set when you want the cameras to record, if you want the cameras to record, if you want alerts to trigger. Any kind of intelligence resides in the DVR itself, not in the cameras. The cameras are completely dumb. Basically, they continuously stream video back to the DVR regardless what happens. They just keep pumping video to the DVR, and then the DVR figures out what to do with the video. IP cameras are different. IP cameras, again, you have the lens and you have the camera, but they are computers unto themselves. The camera itself has intelligence. So when you plug the IP camera into your local area network, it will be able to get an IP address, or you can assign it a static IP address, and then you can go in and you can do a lot of things within the camera itself. You don't need the DVR. Within the camera itself, you can set a lot of configurations. You can set within the camera how recording will happen. So for the camera itself, you can tell the camera whether or not it will record all the time or will record only when there is a motion. You can do things like in the camera. Many of these cameras have internal storage. So you can tell the camera to write video to the internal storage. Or you can tell it to write the video to an FTP or file server that is on the network. All of those configurations reside within the IP camera itself. So when you're dealing with the analog camera, you really can't do anything with it. You can plug it in. If it turns on and works, great. If it doesn't, buy another. That's about all you can do with an analog camera. With an IP camera, you can go in, you can change the IP address, you can change default gateways, you can change when it will record, you can change the resolution it will record at. There's a whole bunch of configurations. Essentially, almost any configuration you would find in that DVR, the digital video recorder, you will find in each individual IP camera. This is one of the reasons IP cameras are so much more expensive than analog cameras, is because they are in fact computers unto themselves. So you can do a lot of fancy stuff with IP cameras. When I had my shop, I used 2 of these 5 megapixel IP cameras, And all the configurations were in the cameras themselves. They simply streamed video back to a plain old FTP server. So the place that they stored all their video was nothing more sophisticated than a Linux FTP server. All the intelligence resided within the cameras themselves. When you're dealing with these IP cameras, you will hear of something called NVRs, or network video recorders. So with analog cameras, the main command server, the main video server, is called a DVR, a digital video recorder. In the IP world, the main server is called an NVR, a network video recorder. That network video recorder is able to go out and communicate with all of the computers or all of the cameras that are on the network. So just like you would sit down at a Windows Active Directory server and be able to change configurations for the entire network at that one server, that is what you can do at most NVRs, network video recorders. So since every single camera on your network has its own configurations, it can take a long time to change those configurations for 20 or 50 or 100 different IP cameras. Well, these NVRs, these network video recorders, you can sit down and you can propagate out all of the changes out to all of those cameras at one place. So that's one reason why people use NVRs. So that's going to be one thing that you have to think about when you're using IP cameras, is you don't need that centralized server the way you do in the analog world. You can simply put up IP cameras that all point back to a single FTP server just for file storage, and that's it. They can go up, and you don't need any other kind of sophisticated server. Or if you're doing a very sophisticated build out of your surveillance infrastructure, you will want to use an NVR network video recorder, because that will be able to go out and communicate with all of these different IP cameras on the network. So the big thing to remember with IP surveillance cameras is that they are computers unto themselves. This is very good. It can also make things very complicated, because again, with analog cameras, you plug them in, they either work or they don't work. It's very simple. Within 5 seconds. Yes, this one's good. Nope, it's broken. It's that simple. With IP cameras, you have all the configurations that you would find in a computer. So if somebody messes up the IP address, that can cause problems. If somebody messes up the subnet mask, that can cause problems. Somebody messes up the default gateway, that can cause problems. If somebody, doesn't check the right checkbox within the camera, that can cause problems. So that's the big thing to understand. When you're going to be working with these IP cameras, you can configure them simply by going to the IP address in any standard web browser. So whether you use Internet Explorer or Firefox or Google Chrome or Safari, if you want to configure one of these IP cameras, you simply just have to know its IP address. You plug that IP address into the address bar, and then you get a little login screen. You log in, and you'll be able to see all of the configurations that IP camera has. When you're dealing with IP cameras, another thing that you have to keep in mind is, since there's a lot of intelligence in there, since these cameras can do a lot of things, many times you have to purchase additional licenses to unlock features of the IP camera. So again, now that we're getting to the computer world, things get more complicated and can get more expensive. So when I buy my IQ and Vision cameras that I love, I think they're the greatest cameras in the world, one of the things that I really hate about them is after I spent $1,500 on a camera, if I want that camera to have the ability to record to a FTP server, I have to spend an extra $60 on a license to unlock that feature. So this is something to keep in mind if you're going to be installing these cameras for a client of yours, is that there can be costs associated with each and every feature that the camera has. So with the IQ and Vision cameras, if you plug them in and you already have an NVR, a network video recorder, then you don't need to buy anything else. But if you want that camera to be able to send video back to something like an FTP server, you do have to buy a special license key for each individual camera. That'll cost you $60 or $70. This can increase your price a lot. Again, with IP cameras, as we talked about in the digital surveillance camera course, Resolution for IP cameras is not TVL. So analog cameras they use TVL for resolution, which is called TV lines. With IP cameras, they use the normal resolution that you're probably used to for your monitor. So basically, how many pixels? 1080 by 1900. That's the resolution that they use. As you go up, you can look at one of the charts, but 5 megapixel cameras are able to capture a certain resolution. 10 megapixel cameras are able to capture a bigger resolution, a bigger shot of an area, etc. That gets a little complicated, so go and look at the chart and it'll be able to show you what the resolution of the camera that you're going to buy is. The important thing with the IP cameras and resolution is to remember that not all IP cameras are megapixel cameras. So megapixel cameras are high definition video cameras. So they are able to record video at the same quality you're seeing me now. So the camera that I use to record these videos is a 1080p camera. So if you use a megapixel camera, it will be high definition, right? But not all IP cameras are megapixel cameras. So you can buy IP cameras with very, very, very low quality video, like even worse than an analog camera. Again, why this is important is if your client buys an IP camera system from you and expects that all the cameras will be megapixel cameras, you could run into issues. So you go out, you install all these cameras, the video resolution is very poor, well, then they're going to bitch and scream and it's all going to be bad. So the big thing to remember with IP cameras and resolution is that you can buy incredibly good resolution. You can buy 20 megapixel IP surveillance cameras that are amazing. One camera can look at an entire parking lot and see it crystal clear. You can also buy cameras that are so crappy that it couldn't make out a face, 15 feet away from it. So just be careful when you're buying these IP cameras. The resolution goes all the way from $50,000, absolutely amazing, all the way to $50, really, really pretty crappy. So that's kind of an overview of these IP cameras. Again, the big thing is that IP cameras have intelligence built into them, and if you're going to be working with IP cameras, you have to understand basic networking. You have to understand what a TCP/IP address is, a subnet mask, default gateway, what a LAN is, what a router is, what a switch is, etc. Because your IP camera is going to be sending all of the video over your local area network, over your network infrastructure. So if you don't understand IP addressing and all that, it's not going to work very well. Let's talk about some of the networking considerations that you need to understand if you're going to be installing IP surveillance cameras. Now, the first thing that's really cool that I love about IP surveillance cameras is that they can be powered over PoE, or Power over Ethernet. PoE, Power over Ethernet, allows you to transmit power over the Cat5 cable that you're going to be plugging your camera into to connect to the local area network. So you don't have to run multiple cables to your camera in order to both connect it to the network and power it. The network connection and the power can come from the one Cat5 cable that you're already plugging into it. If you want to use Power over Ethernet, there's two ways to transmit power to that IP surveillance camera. The first way is to buy a PoE switch, a Power over Ethernet switch. So this can be a Cisco switch, a Linksys switch, whatever kind of switch you want to buy. Basically, it is simply a feature that is built into the switch that you'll buy. So you can go to newegg.com and you can scroll through and you can do a search for PoE switches and buy whatever one comes up. What happens is the ports within that PoE switch will be able to put power onto the Cat5 cable that goes to the camera, and then the camera will be able to grab the power off of that cable. That's all the PoE switch does. The other thing that you can use to power your PoE camera is what is called a power injector. So with a power injector, what happens is it's a power adapter that you plug into the wall. Then from your switch, you plug a cable into the in port of the power injector, and then you have a cable that comes out of the output of the power injector and goes to your camera. This will then feed power to your camera. That is how simple Power over Ethernet is. You don't have to do any configurations, you don't have to do anything fancy. Basically, you just plug the stuff in and it works. Again, I will give you the warning when I give you, warnings about buying stuff, is you are dealing with power when you're dealing with Power over Ethernet, and you're dealing with sensitive electronics. I would not buy the cheapest Power over Ethernet power injector or switch I could get my hands on. You want to buy a good quality switch or good quality power injector. The reason is if it sends too much power to your surveillance camera, it could end up blowing up your surveillance camera. So if you spend $1,500 on a 5 megapixel IP surveillance camera, and then you spend $100 on the cheapest Power over Ethernet switch you can find, if that switch ends up sending a burst of electricity to that camera, it could then blow out that $1,500 camera. If you have 8 cameras plugged into that one switch, you may blow out, $16,000 worth of equipment simply because you were trying to be cheap on the Power over Ethernet switch that you were going to buy. If it was me, I would say go with Cisco Power over Ethernet switches. I know everybody's going to do whatever they want to do. All I would say is make sure you buy high quality Power over Ethernet equipment, because again, if they send a surge of electricity down one of those network cables, you can fry a $1,500 or $2,000 camera in a heartbeat, all for saving a couple $100. I don't think it's worth it. Now, when we're dealing with these IP cameras, the big thing to remember is we are now sending video over the local area network. So before, when you're dealing with analog cameras used coax cable. So analog cameras don't communicate over the local area network. So they can send data back to that DVR 24 hours a day, and it doesn't matter. It doesn't cause any congestion over the network. It doesn't do anything weird on the network. With these IP cameras, whenever they're transmitting video back to the NVR, the network video recorder, or back to an FTP file server, whenever they're doing that, they are using your local area network, your whole IP network. So if they send too much data back, if they cause congestion on the network, they can make it so you'll have issues with all the other networking that you're doing. So if you're doing voice over IP, if you're transferring files back and forth between other computers, your IP cameras can actually take up all of the bandwidth by sending data back to the NVR, the network video recorder. As I'll show you upstairs, my one little 5 megapixel camera can burn up to 30 megabits per second when it is recording full blast. So when I'm recording at 5 megabits per second at 15 frames per second, it uses 30 megabits per second on my network. So I'll show you on the little task manager. That means if you had 4 of those running on your network, they could use all of the bandwidth for a 100 megabit per second network. So almost all of us, very few people have actually upgraded to a full gig network. Most are using a 100 megabit per second network. So even if you have Cisco equipment, even if you have the best networking equipment in the world, if you have 4 megapixel cameras all sending data back to a server all at the same time, they will use all of the network bandwidth. So anything else going on your network won't work very well. It'll be congested and slow, and everything just gets really, really bad. One of the things that the IP surveillance camera companies have done in order to try to prevent this congestion on the network is they have come up with a concept that is called pushing intelligence to the edge. So in the old days with the analog cameras recorded video all the time. They were continuously recording video, continuously sending it back to the DVR, the digital video recorder, because it didn't matter. If they sent video 24 hours a day, it didn't cause problems for anything else. Now, if you have 100 cameras on your network and they all try to send data back to a central server, that can cause problems. So now the intelligence, what they do is they push that intelligence to the edge. So this is why the IP cameras being smart matters. So now within the camera itself, you can configure when it will record video. So you can say what hours of the day it will send data, video, back to the file server or the network video recorder. It will say whether it is going to send video back all the time, or if it will send video back only when there is motion, or if only when there is a motion in a certain area of the video. So in the old days, video was always getting streamed back to that DVR, that digital video recorder. Now, since the cameras have some intelligence, those individual cameras can now decide when they are going to transmit video back to that central NVR network video recorder. That is called pushing intelligence to the edge. There's something called video analytics that's coming along in a few years. But basically what's going to happen is more and more of this intelligence is going to get pushed to these individual cameras. And then that will give the cameras the ability to decide when they are going to send video back to these NVRs. So sometimes I've seen them talk about where there will be internal storage on each individual camera, and then at a certain time each individual camera will then dump all of that storage back to a file server. So let's say during the day you don't want congestion on your network, so all these individual cameras are storing up all the video throughout the day, and then after everybody's gone at home at night and you're not worried about congestion on the network, then all the cameras on the network would then do a massive dump back to that main server. These are the kind of things that pushing intelligence to the edge allows you to do. But basically with pushing intelligence to the edge, that intelligence is now going out to each individual camera. So in the analog days, in the old analog cameras, all the intelligence was in the DVR. Now the intelligence is spread out through the entire network. The cameras themselves can start to make decisions. Now with this, with all of these cameras trying to transmit the video back to a central server, no matter how well you program the system, you can run into problems where these cameras can create congestion on the network. If you're dealing with a real business with 20 users, 100 users, 1,000 users, you don't want to have congestion on your network, especially if you're using voice over IP phones and if you're doing anything where your users really need to be able to use a network to get onto websites, to use web apps, etc. One of the concepts that has come up is to then create what is called parallel networks. So the idea initially with what's called convergence, the idea is that surveillance cameras and computers and voice over IP phones would all use the same network. That is called convergence. The problem is that you can have congestion on the network when all these different devices are using the same network. So now they're breaking it out and creating what are called parallel networks. So now what they're doing is your IP, your surveillance camera system, will actually get its own switches, its own VLANs, its own routers. It will be on its own LAN. It will be on its own network, physically separated from the computer network, and many times physically separated from the voice over IP, the telephone network. So if you walked in to a server room, you would have, let's say you have the cameras here. So you have the cameras, you have the computers, and you have the phones. Well, now they go to their own networking equipment. So they'll have their own switches, they'll have their own routers, they'll even have their own servers. And so if there's a congestion on your IP camera network, it only affects your IP camera network. It's not going to go over and affect your computers and affect your phone system. Then what they do is they simply, using routers, they then connect these systems in the middle with routers so that they can now communicate with each other if they need to. But the big thing with parallel networks is now, especially for your surveillance system, you generally want it to have its own switches, its own routers, all of its own networking equipment, so it is physically separated from your other networks, from your computer networks and from your voice over IP network. Again, because as I'll show you, one single 5 megapixel camera uses 30 megabits per second. If you have 4 of those on a network and then you have 100 users on the same network, it's just going to get messy. It's just going to be ugly. It's just going to be horrible. So these are some of the networking issues that you need to think about if you're going to be using IP surveillance cameras. The first one is power over Ethernet. This allows you to power your IP cameras using the network cable that's already connected to them. So you don't have to run another power cable to them. With this, you use either a power over Ethernet switch or a power over Ethernet injector. You decide what product you want to buy, etc. I would say buy high quality ones, because remember, this is sending power over that Cat5 cable. If there's a burst of energy coming out of that switch and it goes into your $1,500 camera, you can fry that $1,500 camera that quick. If you have 8 $1,500 cameras, you can fry 8 of them that quick. So I would say buy Cisco power over Ethernet gear, but that's your issue. As we talked about, these cameras, 5 megapixel cameras, can use 30 megabits per second. If you get a 10 megapixel camera, it can burn even more bandwidth. If you have too many of these on your network, again, it'll congest the entire network. So what they do is, it's called pushing the intelligence to the edge, where you push, so the cameras now have intelligence themselves, and the cameras decide when they record or when they don't record. They decide, okay, I'm seeing motion, now I will send data back to the NVR or the network video recorder, and when they don't see motion, then they don't send data back. That tries to eliminate the bandwidth congestion that would happen if they all try to transmit at the exact same time. The big thing, though, with IP cameras is the idea of parallel networks, where you will actually create a physical network for your IP cameras that is different than the network for your computers or for your phone system. That way, if any of your cameras, something goes wild, there's a glitch, one of your technicians does something stupid, it's only going to mess up your surveillance camera network. It's not going to bog down all of the other networks that you have. But these are the big issues that you're going to have to be thinking about when you decide to start deploying IP surveillance cameras on your network. One of the biggest concepts when you decide to use IP surveillance cameras is something called virtual PTZ, or virtual pan tilt zoom. So in the digital surveillance camera class, we talked about pan tilt zoom cameras. These are robotic cameras, so they move to the left, they move to the right, they move up, they move down, and they can zoom in and they can zoom out. So when you see Tom Cruise in a movie running around and cameras are following him, that is a PTZ camera, a pan tilt zoom camera. The problem, though, with pan tilt zoom cameras is, if you put a pan tilt zoom camera up to do surveillance on something like a parking lot, if you see something going on that you think is suspicious, and so you move the camera and you zoom in on whatever's going on that you think is suspicious, that camera now only sees what you are zoomed in on. It now no longer sees everything else that is going on. So if you see something suspicious going on here, and somebody is breaking into a car over here, well, then you're not going to see it, you're not going to record it, it's just going to happen. You're not going to have any evidence. Well, with these IP megapixel cameras, you can now do something called virtual PTZ. So the quality of these IP megapixel cameras can be just totally insane. You literally can have a single camera that looks at an entire mall parking lot and can actually zoom in and see individual faces on that parking lot. So it can look at an entire parking lot, and the resolution is so good that you can go in, you can pick out individual faces, and you can be able to see who it is. So what virtual PTZ allows you to do is, you have one of these very high-end megapixel cameras looking at something like an entire parking lot, and then, since the resolution is so high, if you see something suspicious going on here, you can simply zoom in on the overall picture to see what's going on here. The resolution is so high, the camera is still looking at the entire thing. So the camera is still looking at the entire parking lot, but you have simply zoomed in on the picture to zoom in and see what's going on here. So if somebody is breaking into a car over here, the camera itself is still recording everything. So if you're looking at something suspicious here, and then you go, oh no, that's not really suspicious, and then you see a car was broken into over here, well, you will still have the recording of that happening. So all virtual PTZ means is that you have a super high quality megapixel camera. So you have a 10 megapixel camera or a 20 megapixel camera, and with the video feed, you can zoom into certain areas And while you're zoomed in on that area, the camera is still looking at the same thing. So it's looking at the entire parking lot. With the old PTZ cameras, the robotic cameras, if you want to look at something here, it'll turn, it'll zoom in, and then all it's seeing is this. If something happens over here, it's not going to get recorded, it's not going to be seen, etc. With the IP megapixel cameras, the camera looks at the entire field of view. You can zoom into simply one place on that picture, but it's still recording everything else that's going on within that field of view. That's all virtual PTZ is, but that is a very important thing with IP cameras. I know a lot of you probably gag, you probably choke, probably have a small heart attack when I talk about $20,000 surveillance cameras. But think about this. One $20,000 surveillance camera can look at an entire parking lot and see what's going on in an entire parking lot. If you try to do that with the old analog cameras, so fine. The old analog cameras only cost you $500 a piece to install. But you need like 100 of them to be able to cover a parking lot very well. Because the quality of those old analog cameras is just so poor. So you literally have to go out, not only would you have to buy all those $500 cameras, but you'd have to install them, you'd have to figure out a system to be able to manage them, etc., etc., etc. That is why one $20,000 camera can be far less expensive than the cheaper cameras. Because you can have this 1 megapixel camera, again, it can look at an entire mall parking lot and zoom in to little particular areas just fine and record all at the same time. So that's the big thing with the IP's megapixel surveillance cameras, and that's what virtual PTZ is. So as I've been talking about, the intelligence of these IP surveillance cameras resides in the camera itself. So most of the intelligence is in the camera itself. So with that in mind, we're going to do a demonstration. I'm going to open up a web browser. I'm going to go to the IP address of a megapixel camera that I have set up, and I will show you how all this works in a demonstration. I'm using an IQ Envision camera. Again, they don't pay me a dime. There's no sponsorship here, but I think they are very, very, very good cameras. If you're going to be using IQ Envision, then everything I show you will be pretty much similar to whatever you use. If you decide to use a different type of camera though, remember that it will have different features, it will have different functionalities, etc. What I'm going to be showing you is an overview of what cameras can do. What the specific camera you purchase does might be slightly different. So again, as I've talked about in this entire digital surveillance system track, make sure you understand what you're buying. I can show you what certain cameras can do. Whether the camera that you buy will be able to do that might not be the same thing. So let's go over to my computer. Again, I'm going to open up a web browser. I'm going to go to the IP address of the megapixel camera that I have set up, and then I'll show you the configurations and all the fancy things that a megapixel IP camera can do. So here we are at my standard Windows 7 professional computer with Internet Explorer 9 open. So whenever you're going to be dealing with these IP cameras, you will most likely use a web browser to change the configurations. So you just need the IP address and a web browser. You can use Internet Explorer or Firefox or Chrome, etc. So I know the IP address of this camera is 10.1.10.9. And now I can go directly into the camera. So this is the camera itself. This is not going through a network video recorder or a digital video recorder and any other server or anything. This is the camera. So this is what the camera is seeing right now, the second. So right now we're looking down at my living room. Now I've been talking about the virtual PTZ function. So the virtual PTZ is where the camera keeps recording the entire field of view, but then you can zoom into certain areas to try to see what's going on. So this is a 5 megapixel camera. So this is a pretty good camera. It's about a $1,500 to $2,000 camera. This is 30 feet away from a newspaper, and this is the quality you get. So this is something to keep in mind with the quality of cameras. If I wanted to be able to zoom in and see this newspaper, I would probably need a 10 megapixel or 15 megapixel camera to do that very well. But with the virtual PTZ, even though I'm zoomed in right now to look at this newspaper, this camera is still recording everything else that was going on
in this entire field of view. So this is, basic live view. You can go in, you can zoom in on stuff, and you can try to see what's going on, and then you can zoom out again. This up so that the camera is able to record what's going on. So now I can go over to the playback tab, and I can see what this camera has recorded previously. So right now this camera is recording to an FTP server that I set up. I actually set it up on this computer. So on Windows 7 I installed the FileZilla FTP server, and so I can go on the camera and I can say I want to see what happened on the 28th. So I can click on the 28th and do find, and oops, yeah, it's always, things get buggy. Let's see, 28th, and I can see that somewhere around noon was when it was recording. So I can click here and I can see that this is what was happening at 12:28 a couple of days ago. I can hit the play button and look, I just saw all of the recording functionality and all the playback is happening on the camera. So I go to the IP address of the camera to be able to record and to be able to view. The camera then, in this particular instance, dumps that video onto just a dumb FTP server. So it's not a network video recorder, it's just a FTP server. If I want to go in and I want to change configurations for this camera, I can go to Settings. And this is where we get into all the fancy configurations that you can set up for this camera. You can set up the quality of the image. So when it's recording, what quality do you want? Do you want super fine, fine, high, medium? The shutter style, what's called light grabber, frame rate per second. So we talked about frames per second before, where 30 frames per second is real time, 15 frames per second is perceived real time, etc. So we can say here, how do we want this camera to record? Do we want it to record it at 15 frames per second or 1 frame per second, etc. Live page, you've got all these different configurations here. We can go to Window. We can crop the view that you're seeing for some reason. We can go to networking. This is important because remember, this camera is a computer device. So just like you would set the IP address on a Windows 7 computer or a Linux server, you have to set the IP address and the host name for this camera. So the IQi755 name, this is the host name or computer name. Then you have the IP address of the camera, the subnet mask, the default gateway, name servers, ports, etc. All of this stuff is in here. And you'll see it even has fancy stuff, like you can set it up to use an email server to send out alerts. So the camera itself will send out the alerts. There's security. You can go there, just username, password, that kind of stuff. Then we can go over to the IQ recorder settings. This again is where you can put in a lot of different configurations. So do you want this camera to send video back to the FTP server all the time or only when there's motion? So right now it's sending back video all the time. What resolution do you want it sent back as? So this is a high resolution camera, so 2560 by 1920, or you can scale the resolution down. You can go all the way down to 320 by 240 if you wanted to. Minimum number of images, recording rate, all this kind of stuff is in here. Now here, the network recorder settings, this is where I've set up the FTP server for this camera. So the FTP, the IP address of the FTP server is 10.1.10.100. The username is DVR and the password is 123456. So this camera, whenever it does record, will try to send that video back to this FTP server. This is where you put those configurations in. Then we can put in like the storage limit. So I have a terabyte here, 1,000 gigabytes. So I can say this is how much video I want to store. And when you hit the maximum, what do you want to have happen? Do you want it to overwrite what you had before, or do you want it to stop recording? All this information is in here. So this is the basic configurations that you can put into an IP camera. I showed you the analog cameras and the digital surveillance camera class, and I showed you there's only a couple of settings. You really can't do a lot with an analog camera. With an IP camera, you can do all of this and much, much more. The main thing I want you to realize with these IP cameras is that they are computers unto themselves. if a computer can do it, then it can do it. So I mean, this is a minimum. You know, you can do much more with IP cameras based on the specific IP camera that you purchase. So, you know, this is the live view as I was talking about before. I want to show you that we are in fact using the FileZilla server. So this is FileZilla server. So I have the FTP set up on this computer. So this Windows 7 computer. The reason why I want to set it up is to show you how much bandwidth the computer can use with one of these 5 megapixel cameras. So if I go over here, you can see that right now this camera is pushing through 38 megabits per second. So this one single solitary 5 megapixel camera is using between 36 to 38% of the network capacity of this one computer. So if I had 4 of these connected to this one computer, I could crash the entire network. So you have to be very careful with the network utilization when you're using megapixel cameras, because you know this is real. You can see over here, these are all the FTP commands and all that going through, and this is where this particular camera, like I say, is using almost 40% of the network capacity of this computer. So those are the basic things that you should understand when you're configuring an IP camera. So with that, let's go out to the real world for some final thoughts.
So that's the gist of IP surveillance cameras. That's really all there is to it. They are a little more complicated than analog cameras, but if you understand basic computer concepts, if you understand basic networking concepts, I mean, if you can set up a small office network and feel pretty confident about it, then you should be able to deal with IP cameras. They're no more complicated than setting up a small office network. But they are that complicated. So you need to know how to do TCP/IP subnets. You need to know what a default gateway is. You need to know what servers are. You need to know what a megabit per second is, etc. But if you understand those basic concepts, IP surveillance cameras are no big deal. IP surveillance cameras are really awesome. The price of IP surveillance cameras are coming down significantly. When I first started doing the surveillance systems, I don't know, back in 03, all of them were just foolishly expensive. A few years ago when I was installing them, they finally came down to like the $1,000 price point. Now you can go out and you can, I'm not sure I would do it, but you can buy $100 IP cameras. The quality is, whatever the quality is. The warning that I will give you is if you're only going to use one IP surveillance camera, then you can basically buy whatever you want as long as it has the functionality you need. If you plan to plug these IP surveillance cameras into a central NVR or network video recorder, make sure that everything can talk to everything else and plays nice together. So you will see with NVR, network video recorder software, it will say what cameras it supports. And if the camera you buy is not on the list of what it says it supports, it won't work. So with analog cameras, you could basically buy any analog camera you ever wanted to buy, and you could plug it into a DVR and it would work. It would just work. It would be fine. No problems. With NVRs, network video recorders, that is not the case. They have to be created to be able to talk to all of these different types of cameras. So if you look at NVR software, it will say, this NVR will communicate with Toshiba, blah, 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 Sony, blah, 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 IQ Envision, blah, 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 Axiom, blah, blah, blah. It will tell you the cameras that it will talk to. And again, if you buy a camera that's not on the list, then the NVR just won't talk to it. With the IP cameras, remember, there's intelligence in that camera. The configurations reside within the camera itself. So with whether or not the camera will record when there's motion, whether, all of these different criteria, that is in the camera. The concept behind that is called pushing intelligence to the edge. So before, all the intelligence was in the central server, the DVR, the digital video recorder. The cameras were completely dumb. They had no brain power. Only the server had brain power. Now the cameras themselves have brain power, and the central server is able then just to send commands and make changes to the programming that are in the cameras. The reason why that's important, as I showed you during the demonstration, is when one of these 5 megapixel cameras is pushing out video, it can push out up to 30 megabits per second for one camera. And it's doing that 24 hours a day, 7 days a week. So if you have 4 cameras, 4 5 megapixel cameras on your network, you can basically shut down your entire network if they're all pumping data back at the exact same time. So by pushing intelligence to the edge, having the cameras decide when they will send back video, that tries to restrict that congestion. I did talk about how people are now creating parallel networks. So although you can put your IP surveillance cameras on the exact same network, you have your voice over IP system or your computers, it is best to put it on its own network. So its own switches, its own router, its own VLAN, etc. The reason being is because if somebody does something dumb and one of these cameras just starts blasting data in the network, all you will affect is that video network. You won't affect your voice over IP network, and you won't affect your computer network. It's a very important concept. We also talked about the power over Ethernet, so you can power these video cameras using the network cable. You have a power over Ethernet switch or a power over Ethernet power injector. That sends power over the network cable to your video camera. Again, don't be cheap on this. Anytime power comes up, buy good quality stuff. Buy Cisco. Anytime power is involved, buy high quality. You scrimp on something that's sending power to your $1,500 camera, and the chances are that thing at some point is going to blow out your $1,500 camera, or it's going to blow out 8 of your $1,500 cameras. We also talked about the virtual PTZ. So with normal PTZ, pan, tilt, zoom cameras, these are robotic cameras, they can follow you, they can zoom in on you, etc. The problem is if they zoom in on one thing, they can't see everything else that's going on. With these IP cameras, the quality is so good, you can look at an entire parking lot all the time and then just zoom in individually on the picture and see what's going on in certain areas. So if you see somebody that looks like they're breaking in on the video here, you can just click the magnifying glass and magnify that one area. The rest of the video is still being recorded. So if you're looking at something going on here and somebody breaks into a car over here, you're still recording that information. The final thing, again, that I'll say is be very, very careful when you're deciding to buy IP surveillance cameras for your clients, because again, we are now getting into the computer world. One of the real pains about the computer world is you're now dealing with licensing issues and licensing fees. So again, with the IQ and Vision cameras that I purchase, if I use the camera with an NVR network video recorder, I just buy the camera, I buy the NVR, and that's it. If I want the camera itself to be able to store data, store video back to an FTP server, I have to spend $60 to $70 more for the license just for that one camera to do it. So if you're going to buy 4 cameras and you want each individual camera to send data back just to an FTP server, you may end up having to spend $300 or $400 extra on the licensing to do that. That's just with the IQ and Vision cameras. All these other cameras may have their own licensing issues. Basically, any feature that the camera has, you have to make sure if you have to buy a license for that feature to work. So you have to be careful. In the computer world, we're kind of used to this. You buy a product, but even though you just spent $1,000 for the product, now you have to spend an extra $500 to open up all these additional features using licenses. Surveillance systems haven't been like that in the past. Now they are. You buy the camera, and even though technically it should be able to do whatever it is you want it to do, you may have to plug in a licensing key for it to actually do whatever it is. But that's really all you have to understand with IP surveillance cameras. Again, if you can do a small office network, you can do IP surveillance cameras. The big thing, as always, to be careful about is buy high quality stuff, If you don't buy high quality stuff, it's going to go bad. Make sure you know what you're buying. Again, with this whole surveillance system track, if you don't read those specifications exactly, things can go bad. You can buy $10,000 worth of equipment that you can't use. And then finally, the networking issues. The networking issues are not a joke. Again, one single 5 megapixel camera can send back 30 megabits per second back to a server. You have 4 of those on your network and you crash most anybody's network out there. So be careful with how you design the network when you decide that to have the cameras record, etc. This can cause really big problems. So, as you know, I'm Eli the Computer Guy over here for EliTheComputerGuy.com and EverymanIT.com. This was IP Surveillance Cameras. I enjoyed teaching this class, and I look forward to seeing you at the next one.